Hello, welcome back to AC Circuit Analysis. Here we're going to talk about the incredibly important topic of RMS value in power calculations. So if you just kind of take a journey with me, remember way back into the beginning of circuit analysis, DC, long time ago, you learned about power. And you learned about some really simple equations that turned out to be really powerful. P is equal to I squared R. P is equal to V squared over R. That's back when we were just talking about resistors. And then we get into AC and we start talking about power calculations in AC, and we go off the rails talking about crazy long equations with instantaneous power and then average power and then real power, and there's phase angles everywhere, and there's power factor, reactive factor. It's all really important for the theory. And we've done a few problems up to this point, but it has gotten a lot more complicated. Wouldn't it be nice to get back to some of those simpler equations, that we learned a long time ago, like V squared over R, I squared R, things like that? But in the AC analysis realm, wouldn't it be neat if we could use phasors or some other technique so that we could use those simple equations, but using phasors make all the math so much easier, so we don't have to deal with the phase angle differences and all the stuff that we've really talked about up to this point? Well, I'm giving you that pep talk because that's really where we're going. So I need to talk to you about RMS value. I need to derive a few equations. In the next section, we'll talk a little bit more about it, but eventually where we're going to land is we're going to get to a concept in a few lessons called complex power. And it's basically going to combine everything that we've talked about in terms of AC power calculations with the phase angles, but we're going to combine it with sort of phasor notation, complex number notation. And it's going to make all of these calculations of power really easy because you'll be able to use the very familiar formulas that you've used all up until this point, I squared R, V squared over R. But there are some differences. So kind of head out with me on this journey and just kind of understand where we're going so that you can see where we're going to head down the road. But that's where we're going. So we have to start somewhere. So we're going to talk about the idea of RMS. And I know that you've probably heard of this in other classes. Maybe you haven't. But if you haven't, it's called root mean square. And I'm going to explain what it is. I'm going to explain why it's useful for us here. First, let me just write down what it is, and we will talk about the details of why it's important here in just a minute. All right, so if you have a voltage, and we call it the RMS value of the voltage, what is that going to be equal to? It's going to be a large calculation. So what we're going to have is 1 over t integral t naught to up to a top limit of t naught plus some capital T. I'll explain what all this stuff means in just a second. It's not a big deal. Don't worry about it. Vm squared cosine squared, and inside of this we'll have omega t plus theta sub v, and we're doing integration over, I'm going to take that out. That's going to be a v here, make it a little bit clearer. And then we'll have dt like this. That's the integral. And then we have an enormous square root that goes over the whole entire thing and covers the entire thing there. Make sure you understand that square root encompasses the whole thing. Let me just double check and make sure I've written everything down correctly. Everything looks good. All right, so when you have something called root mean squared, this term is very descriptive about what's happening in here. So what you have here, you have some voltage, right? We're calling it a voltage, Vm times the cosine and so on. If you square that voltage, then what you're going to end up with is this part right here, not with the dt. This is the square of v sub t, some function of time. Some voltage is a function of